Alright, hello everybody. Here is what I ate for Thanksgiving. Just kidding, not really, but it would have been interesting. Bacon, duckin', but that's my fun start of the day. Alright, so what we're going to learn today is special cases for linear systems. And basically, the special cases of linear systems are just when you have parallel lines. So I'll give you an example. Y equals 2x plus 5. Let me zoom out here. Let's do 4. Y equals 2x plus 4 and y equals 2x plus 1. So see how these two are parallel? Well, at the same time I can just rewrite these into standard form, so I'll do that. I have negative 2x plus y equals 4, and what I did is I subtracted 2x to both sides, and I can do the same here. I do negative 2x plus y equals, plus y equal to 4, is equal to 1. Right? And I can get rid of these two because it's the same thing. Alright, so when you do elimination, you're going to see the trick here, and when I do elimination I'll go ahead and write it. When I do elimination, let's use these lines. Negative 2x plus y equals 4. 2x plus y equals 4. And negative 2x plus y equals 1. Now, if I'm going to use elimination, you can choose to use elimination or substitution. You'll get the same answer. You make an E. Now, remember, when you're doing elimination, you need to have one opposite of the other. What's the opposite of negative 2x? Well, it's positive 2x. So how can I get this to be positive? I'm going to multiply by negative 1. Is that ugly negative 1? Sorry. That's negative 1. Okay. So I'm going to rewrite another E for elimination. And at the top I didn't do anything, so it's 2x plus y equals 4. And on the bottom one, now it's changed because I multiplied by negative 1. It becomes 2x minus y equals negative 1. And now that I have opposites, I can combine the two. So negative 2x and 2x, well, they cancel out, they get 0. Y and negative y, I also get 0. 4 and negative 1, I get negative 3. I get positive 3. So I get 0 is equal to 3. But hold on, that doesn't make sense, right? 0 does not equal 3. So what I need to do is put a slash mark here. But the trick we learned in class was to remember it by putting another slash next to it. So 0 does not equal 3. These two are parallel. No solution. And I shortened it to sol. Okay, no solution. And no solution, you're always going to have it like this. Right? Because it does not equal to, then you make the other one. Now you know they're parallel. Right? Now let me pause the video and make an example for infinite solutions. Alright, now let me show you guys the other one. So let's start off with the line. We'll do y equals, let's change this to 3. 3x plus 3, and that's what it looks like. Here's the intercept at 3, and it's going up 3 for every one. And I guess you can't see that like that. I'll do it like that. Alright, you're going up 3 for every one. Right? Go over 1, up 3. So let's rewrite this in somewhat of a standard form. You have negative 3x equals y plus 3. 3x plus y equals 3. All I did is I subtracted 3x both sides. It's the same thing, right? So now I'm going to go ahead and change this one to something else. I'm going to take this line, I'm just going to double everything. And let's see what happens. Negative 6x plus 2y equals 6. And that's the same thing again, right? I can just manipulate it a little bit and make it look a little different, but essentially it's the same line. Okay, so now I have these two lines, and let's go ahead and write them and work them out in Paint. Negative 6x, and I learned my lesson from last time. Negative 6x plus 2y equals 6. And the other one was negative 3x plus y equals 3. Now I'm going to do the elimination. Here's my e. I want the opposite of negative 6, which is positive 6. To get to positive 6, I need to multiply the bottom part by negative 2. So I multiply negative 2 on the bottom part. Now I rewrite my e again. And now I have negative 6x, nothing on the top changed. Negative 6x plus 2y equals 6. And on the bottom, it's changed to positive 6x and negative 2y and negative 6. So combining these two things together, I get a bunch of things that cancel out. I get 0 here, 0 here, 6 and negative 6. I also get 0. So I get 0 plus 0 equals 0. In other words, 0 equals 0. So the shortcut to remembering how many solutions are in this is you basically just kind of remove the equal sign and put the zeros right next to each other. What symbol is this? It's infinity, right? I kind of drew that a little uglier, but this is the infinity sign. So when you have infinite solutions, that means you have a line on top of the other line. Alright, so that's infinitely many solutions. You have infinite solutions. Okay? So when you have 0 equals 0, well, it looks just like the infinity symbol if you take off the equal sign. So it's infinite solutions. Okay? So infinite solutions means you have two lines and they're hitting each other constantly because they're the same line, right? So one on top of the other, they're the same line. Infinite solutions, you keep hitting each other. Okay? And one solution is the most common one. It's just two lines, they're hitting each other like this, or like this, or like this. Okay? And parallel is just, they're parallel swag. Okay? So that's it for special cases. You can do them all by doing either your substitution or your elimination, and you'll see it. Like once you get the answer. That, or you can just look at the graph and you'll see that it's parallel, or it's the same line, or they just hit each other at one point. And that's it. See you guys in class.